All right, let's get started. All right, I'm going to be using Tauri for this stream. So I'm going to just run the required command line. Do new terminal, and we'll do this command. And then we'll do a quick guide to see how to start. Okay, so that might actually be enough. It is. So before I do that, I want to cd to documents, and I'll rerun this command, and we're going to call it tappy lane. We'll go with that identifier. We use TypeScript, JavaScript. We'll go with bun. We use React just in case we need the flexibility. Okay, so we're gonna go to File. We're gonna go open folder. Go to Documents. Click on Tappy Plane. Open that up. We're not gonna save it. Trust it. Okay. So let's look at the README, see how we can, I guess, run this. Okay, how about we look at the package? So there's dev, there's build, review, there's Tauri. Okay, so maybe look back here. After we chosen everything. And there's Tauri dev. But we gotta do bun install first. So let's open the terminal. And no agents. Oh, I probably wanted that. So we're gonna do bun install. And I'm gonna do bun Tauri dev. I guess that means I don't have Rust installed. So let me just verify. I will. Yeah, I probably don't have. Yeah, I don't have Rust, so Homebrew install Rust. We'll do it like that. And let's grab the media that we want. So we're gonna download all of these. And then we'll go back to here. Open up our downloads and find that folder. Which is called Tappy Plane. Okay. I think that's gonna go into our public folder. So I'm gonna, hopefully I can copy this folder and paste it. No. We'll call this graphics. And then we will hopefully we can run Tauri dev. Just let that run through. And certainly going to do something in the app. We'll go to app. We're going to see what the default app looks like, but we're likely to just delete it all. Excellent. All right, so hopefully it's going to be a live reload. I think we need all that. We're just going to clean this up a little bit. Get rid of that, rid of that. Call this div. Put the canvas here. Set it to 640, 480. We'll save it. I guess there's really no way of knowing. So what we're gonna do is do a ref, canvas ref. And we'll say const canvas ref equals use ref. And this will be HTML canvas element or null, and this will be null. And I guess we could get rid of this for now. And we have app CSS. None of this is really used. I don't even know if we want to keep it. So we want to use state to keep track of the size of the window. Do size set size equals use state. Width is window.nar width, and height is window.nar height. I'm actually gonna turn off Copilot. Go back to the app. Use state comes from React. And we'll do use effect. It's like const. What's doing this? What's causing this to happen? Do const, I don't know what it's called. I'll just use the autocomplete for that. And then we also have to add the event listener. And then we actually have to use size. So let's do a black background. We could do it as a class. We don't even need a class. We'll just select by element. Save it. Are we getting... Okay, so we do see the canvas. Next we want to do body. I think it's margin. Great. And then we have like what we would consider to be our desired width of 640 and our desired height of 480. But we actually want to stretch the canvas a little bit to fit the screen. And on top of that, well, that's interesting. Style, and then we'll do width is, we don't need the background there. Okay, once that on new lines. So we actually need to figure out, we do want to do something with width here. We do want to do something with height here. Actually, I think that's just going to be width and height, and these are going to be something else. Because this will be our scaling factor. So the next step, I guess we want to know what the scale is. And we're going to want to know something like this. So we'll just times this by scale. And if it's wrong, we'll change it later. For the canvas, we need to do position absolute. Top is 50%, left is 50%, transform is minus 50, minus 50. And we'll pull it up. And we should be able to resize the window, and the canvas resizes with it. And it stays centered this whole time, which is happening. This is exactly how I expected to behave. So that's great. So the next thing we want to consider doing is adding another use effect. We actually want these to be in, to only happen once. And hello, Maywar. How's it going? Do all of this, but I think we're going to create a new file to track all of this logic. So we'll do a new file. We'll call it game.tsx. Is this a side project? Yeah. Call it a side project. Just something I decided to do today. Randomly. Something I've been wanting to do though. But literally just starting today. Started just a few hours ago actually. I'm just very curious about this Tauri library. Well, I know basic Python and R for data analysis. Okay. I do enjoy Python. R, R is questionable. Not a fan of it. But hopefully, yeah, there are some skills you could pick up. I think that there are some transferable skills from language to language. But yeah, I'm going to do const draw. And maybe const update. Something like that. I'm assuming that you do some kind of research or science if you're working with R or Python. We're gonna have like a concept of a state. So I'll create an interface state. And it'll also store information about the game itself. Maybe something about like the lane X, lane Y, health informatics, pipelines, Nextflow, health tech and stuff. Cool. I feel like I don't know what half those words mean, but it's awesome. Glad you're here. If you have any questions about what I'm doing, I know it seems pretty new, but if you have any questions, just let me know. I feel like we really need to know the why, call it velocity Y. I guess the angle, plane angle. And this will take state and return state. So return state, this will take state, state. There's probably more information that we need. Oh, thank you. Appreciate that. So from here, I want to start calling those functions, I guess. I think I want to do request animation frame. And I think this will actually be actually maybe we should call it, how do we want to call this? Probably because we want to keep we don't want to have to like keep getting these cached values. So we want a nice way to, okay, here's what we're gonna be able to do. Const process, and then we'll call process. But at the beginning of process, we'll do request animation frame process, and then we'll do draw state. And I was actually thinking of doing a state variable, but we can actually do something like this. And then we can start it in the middle of the screen, no velocity. We need to know how tall the plane is. Let's import state. We didn't export it. Should probably export everything from this. Game, yep. Do draw state, draw comes from game as well. We'll do update state. Update comes from game as well. And then we'll do state equals update. Just like that. And so that should hopefully give us a plane that is, well, we haven't even loaded or drawn the plane, but we could draw a box at the very least. Probably going to be a good idea for these to take extra arguments. So this should maybe take a context, HTML context, canvas context renderer. What is it? Canvas context, canvas rendering context 2D. Okay. We'll clear the rect. And we'll do context.fill style. There's actually a really nice drawing library called Pygame that has very similar functions if you ever wanted to like draw things on the fly. You would have basically the same access to pixels and functions that draw different shapes and paths and whatnot. So that's an option if you're interested in doing any kind of more graphical representations of data. That kind of goes outside of the realm of the built-in graphing options of Python. We want to know let's do gravity. Export, sure, let's do lift. Export const. Sure, let's do max velocity. I think I'm kind of torn whether to call this just velocity or velocity y, because I don't think we'll have an x. So I just want to see that we're drawing. I think it might have, did it crack? Okay. This takes canvas. Not a canvas, a context. And we just call that CTX. I don't really like short variable names. Try to avoid them if I can. Okay, so we are drawing our plane. Okay, so I think one thing trying to determine whether I want. It's called tappy plane, but I don't know if that means that I want you to hold certain keys down. Also, how am I going to detect key down? I think I need to do something where, to the effect of dot add event listener key down, so it's reading my mind. Plane velocity, will it just instantly go? I think I gotta do lift here. And then we also have to care about how many frames have passed. So that's pretty important. So rather than handling this here, we might want to just say like space pressed. And then we say this. And then we got to add that variable. So we also need to add a key up for the same thing. And then we got to do due date now. And we should do, or date last const now equals date dot now. We'll do a lot of this. I don't know the point of that. I want to do delta. We'll make that second argument of update. We'll give this delta. Delta, let's divide by 1,000, so it's the number of seconds. And we'll basically say if state dot is space pressed, we'll apply the lift, else we'll apply gravity. And we need to rotate this by the velocity. So context dot rotate, and then this will be the actually we don't need the angle. Angle is determined by the velocity. Yeah, it's determined by the velocity. And so we want to know the angle. So I'm gonna just put a comment if the angle between the center of the plane and the velocity. We'll do const a equals I'll say x is plane's x, which is 50. Sorry. 50. Y is state.plane y, and then const b equals x is 100. And then the y is state dot plane y plus state dot plane velocity. And then with that, okay, hopefully that's the angle we want, and that's the angle we use here. And do that. Oh my goodness. So we do want it to stay centered. So we got to think about the order of operations here, because rotate, we need to do a rotate, we need to do a context dot translate. We also need to know the plane width, the plane height. Which we need to open our graphics. Look for the plane. Oh, excuse me. 88 by 73. Yep. So it's 88 by 73. Cool. So we'll use those variables here. Plane width, plane height. Is that a function? I did not know that was a function. It's cool to know. I think I'd rather do context.save, context.restore. So we basically need to imagine that this is, okay, so we're gonna do plane width divided by 2 negative plane height divided by 2 also negative, and then when we draw it we'll do plane width divided by 2 plus 50 plane height divided by 2 plus. And so I think like order of operations, it does things backwards. It'll translate it first, then it'll rotate it, then it'll offset by these things, I believe. That's beautiful. So let's also put, actually, yeah, let's put the plane offset equals, we'll call it plane offset X. Fine. We'll call it game width, game height. We'll prefix that here, here. We'll go into here and prefix it here and here. We'll prefix it there. There's no longer an angle. Keep prefixing. All right, check it. Oh, I crashed, I guess. I'm hoping to have it not slide. We can close this, we can close this. so we could start replacing some of these. This is the plane offset X, and this will be plane offset X plus plane width divided by 2. Plus plane width divided by 2. This should just be plane width. Basically, yeah, the center of the plane to the front of the plane. Oh, hello. Hi Hardik and Lokesh. Sorry if I'm saying that wrong. Welcome to the stream. So we do plane width, and this could be plane offset X. This is plane Y. Why am I doing -10? I don't know. Plane height divided by 2. I think plane Y should also be the center. Which means this needs to be offset, and this needs to be offset. And I guess one thing we could do is draw these points. So we could do context dot ellipse, and I don't know if we need to begin path for this. We do need to set a color though. Okay, well, it seems like we're not clearing. Correct. Or it's because we're not. We need a context begin path for each of these. And let's do them in green. We'll do the plane in red. And then we'll do the spots in green. We'll do them last so that we can see them. Alright, we crashed, I guess. Okay, well, these aren't appearing where I want them to, so I think that the rectangle is appearing where I want it to. So I'm gonna turn off the rotation. Can we get this product after you're done with it? Yeah, sure. I'll commit it and share a link for sure. Why do I keep crashing? Okay, so this box looks centered to me. I don't know if I need to pull out a ruler, but take the plane width divided by 2, offset X. What, do we even need this? Yeah, we do. This is centered. Plane height divided by 2. So the issue is with these dots. They're too low in the Y. Okay. And then we can resize this and everything scales as we expect. Yes. Okay, this one should be getting lower. That is correct. Because the gravity is applying to the nose of the plane. Could make gravity 10 just to see what happens. It does make it dip more. And we gotta figure out the order of this. Oh, so we only do this because of the rotation. So this is actually just offsetting it by X. And this is also just offsetting then plane and then censoring it vertically. So since we're doing this, we could probably just cancel these out. Just use plane, not Y, to save a cycle. Oh, goodbye. Okay. I guess I'll try just changing the order. No. I translate plane. All right, let's remove one thing at a time and see what the potential issue is. We'll do 0, 0 here. Because ideally with just this code, it should just center, it should just spin in the upper left-hand corner. Hello Nexus, how's it going? What is this about? We're attempting to make a game. We're making a Flappy Bird clone called Tappy Plane. And I'm using a browser-based application builder called Tauri to help do it. It uses Rust, so it's a little bit faster than other like Chromium-based applications. But we're starting off from scratch using Tauri. So we have to figure out rotations, for example, which we actually removed the rotation, so it makes sense that it would not rotate. But yeah, I wouldn't have expected it to rotate in quite this way. What if we did the order differently? Seems nice. What if we bring these back? That's where we get an issue. What do you find is the biggest advantage of using Tauri for this project over something like Electron, especially since you're avoiding frameworks? Well, Tauri is newer, right? I guess library for creating desktop applications, but it's also more performant because it doesn't have all the bells and whistles of a browser. Basically, Electron has many of the browser features that you might not use or want. So it's a lot heavier to use Electron, and Tauri itself is Rust based, so it's automatically going to be faster, so they say. And you can actually interop with the Tauri. You could even write Rust if you need like these micro optimizations. If you need algorithms that need to be super fast, you could write Rust code and run Rust code as you need it to do special jobs. So I just think I'm only doing this for performance and because it's newer and probably lesser known library to use. We did something like this. I don't know if I quite answered your question, but if you have a follow-up based on what I said, just let me know. This kind of looks right. It's just not rotating along the center. It keeps shutting down. See, this looks perfectly fine to me. This rotation looks great. Am I just doing things in the wrong order? How are you doing? What about leak code? I'll do leak code later today. I just wanted to take a break. I have a leak code interview tomorrow, so I have to do leak code later today anyway to prepare for that. But yeah, I'm doing all right. How are you? Probably do leak code in like 2 hours. So I'm thinking that it's like this idea of order of operations. And so what I think is the incorrect order is that these both need to be here. I just need to learn how to select the correct stuff. These need to both be here. These need to be here. And this needs to be here. So the idea is that I believe these happen first, then this, then this. I guess we'll find out. We'll ask the computer. Computer will tell us. And there we go. And this is just like simulating the plane kind of dipping. And if I hit the accelerator, I'll start to lift. But it's not quite powerful enough. The lift is not powerful enough in my opinion. And the gravity just doesn't feel right either. And then we need to have like a max. I would say we have to have a max velocity. We'll say the max velocity is 50 for now. And then we'll do state.plane velocity equals math.min, math.max, and we did it in the wrong order. So this will be the lower bound, which would be max velocity. This will be the state.plane velocity, and this will be negative. So we will be bounded. They could probably both be smaller, or probably both be 50. Do type of plane. Okay, and then maybe it'd be good to start drawing stuff now. So let's load some images. And I'm hoping that we could just do slash graphics slash plain dot png. Actually, it's planes. And then we'll do const load. Just like that. And then we could do if it's ready to draw. Actually, should avoid doing any of that. Don't do the fill anymore. And then we will do context.draw image. All of this. And then the restore goes after that. Okay. Oh, I didn't. Let's do this. Let's fill rect. Oh, we didn't put a width or a height. That shouldn't matter. And then we'll do context.fill style equals red. And then we'll run it. Weird, I didn't change that much. Just drawing so many red and nothing green. It's different. Oh, and it crashed. Like, what is this thing down here? HTML image is provided in a broken state. It shouldn't be broken. Just curious. Run it again. In the debugger. Sources. Okay, so we're not able to load the image, it seems. Let's go to game. Put a breakpoint here, hopefully. It does say true though. Curious why that would be the case. Well, I didn't spell graphics right, so that might do it. So graphics, planes. Oh, and then we need the color. Plain blue 1. And Is it the same error? Let's go to network. Close it. Go here, run it. Okay. All right, so we're drawing the plane now. We're drawing the green dots. And then the animations are going to be important. So we'll do blue plane. And we will also, we'll do this for now. And what we're going to do, we don't need to draw this rectangle. We don't need that to be debugged anymore. And then there's some kind of canvas trick to make it draw much cleaner drawing here. Oh, they read my mind, I guess. Let's see if it's smoother. Not really. Curious if it's because I'm stretching it. Probably because I'm stretching it. As it gets bigger and bigger, it gets more and more fragmented. What if I made it true? It's not smoother. What if I... Where's the game? And we'll go to the width. And we'll do 1200, 800. And maybe that'll reduce the amount of stretching that we're experiencing. Make it look a little bit nicer. Okay. I think it's a better size for the plane anyway. So the other thing we want to do is apply the velocity to the plane. So we say state dot plane y. Just do that. Doesn't seem that scary though. I want it to be a little bit scarier. So I'll make this make all three of these 100. It's too easy to save yourself. I think I just fell off the screen. If so, we'll do another state update. If state.plane y is greater than or equal to game height, then we'll say state.plane y equals game height divided by 2. And similarly, else if state.plane y is less than equal to 0, we could just, I guess, put it in the same condition. Basically, if the plane is out of bounds, we should just reset its coordinates. And its velocity. Okay. I think next we want to do animations. So we'll figure that out next. All right, so we're trying to do the animation. We'll do this. And this will be 2, 3. Two. And we'll say const index equals mat or date dot now divided by so how many frames per second? Probably want to do maybe an entire cycle. We'll do math dot floor divided by blue plane length. Now we could do this. This will be blue planes, and blue planes. Save it. And then check it. Okay, so the propeller is moving now. Nice. So that's that. And we could make it spin a little bit faster, maybe. I guess it depends on how fast it looks like we're moving. All right, so maybe we should do a background. I think we want to do like a repeating background. So which one of these is the background? That's the first question to answer. Okay. The const background equals it's just this, and it's called background.png, and we could just draw it. We might even be able to get away with not clear recting anymore. We could just do if background is complete, then we'll do context.draw image, just like that for now. actually going to go into the CSS and I'm going to make the background black on the body. It's just much cleaner on the edges. And now I want to make the background move. And so maybe there should be a velocity. No. I'm wondering how we do velocity y or y x. We'll do that. And we want to make the background move. We'll just make it move at a constant rate. The one thing I would want to do is create a repeating pattern. I'm trying to think of a way to just be a little bit more strategic with it. Create pattern. Background. How can I draw? Okay, so I'm gonna do a little search of HTML5 canvas pattern. Just to get a sense of what we could do with this. Okay, so use the fill style. So I don't know how you could do a pattern offset. Okay, so there might be some kind of pattern offset. We can see if it exists. It does exist. We do x is date.now divided by 1000. Yeah, 0. And then we could do context.fill styles pattern, and then fill rect, and then get rid of this and see what we get as a result of that. Zero might be too slow. Let's just not divide by 1000 for now. And check that out. Okay, what if we divide by 500? We can move twice as fast. $100? Okay, so that transform doesn't work the way I would have hoped. So we might have to do something different. What if we did game width times 2? Something to where you're just like slowly moving this across, and then when you reach the end it resets. That's the idea I have at the moment. Which I think still uses date.now. So you divide by 100. And we'll do date.now. Well, let's call this x. And we'll just see what this looks like. Okay, at the moment we're not drawing background. So we're thinking about this. X is moving. I think we gotta do negative x. So we're divided by 1,000. Looks like we have 2 different planes right now. Interesting. Go back to 0. Run it. Okay. Oh, and that's because this is already, date.now is already super large. So what we should consider doing is getting the background's width. So we gotta like mod this by the background dot width. Maybe, and then actually use it as a negative value, and then run it. It might be too slow to notice, so we'll do 100 for now. We'll do console log of x. And then go back to here, open the debugger, make it large, go to the console. I'll just give me a moment. All right, let's see. I'm currently on hold. Just a moment. All right. We're back. Had to take a recruiter phone call. All right, so we're trying to animate the background and we're just not having any luck doing that. How do I clear? Let's take a look here. Do we have to floor this? I-93. It seems like the logging is super slow. I'm gonna close this. I'm gonna run it again. Okay, but it's just not moving. All right, forget about patterns. We'll do draw image, background, -x. And then this will be two times. And we'll draw a second one at plus background dot width. Hopefully that's good enough. Oh, did it just skip? I think that we shouldn't, okay. We should do game width, not background width. We'll make it go a little bit faster too, maybe. Twice as fast. Oh, that's not right. There's a very obvious clip right there. What if we did this? We did const width equals 100, const h equals 100, and then we did w, h, w, H for now. Now, what if we didn't do, what if this was constant 0? And then what if we made it move very slowly? And then we did a 0, 0 game width, game height. Just W. Let's also do a stroke rect at -x 0 W. What is that? Why is it W times 2? Why is it W times 2? H. And then context dot stroke style. We'll call it yellow, just to make sure we don't have too much of the same color. Let's make it move a little bit faster. Okay, let's make it back to game width. And game height. And then we'll increase the speed again. We got the yellow outline to indicate where the background starts and ends. So I want to see if it looks like it's okay. It's pretty smooth. So we can get rid of the stroke. Cool, and then we can get rid of this clear rect as we're drawing that background. So next we want to maybe add the little puffs of smoke. Or maybe even the stalactites, stalagmites. Actually, let's add the ground. I think the ground would be a nice touch. So we'll do const ground equals load graphics slash ground dirt.png. And then that'll come after plane. If it's complete, then we'll draw it, and we'll just do ground. Yeah, just draw it. And this similar, very similar idea of we only have to draw 2 grounds at once, the one that we're currently over and the next one coming up. And in reality, we don't even need to know we don't need to store what color the ground is. We could just say it's based on some index. But we can say that this is the XY, but the width is game width, and the height is, we could try that. I don't know how it's gonna look. It doesn't look too bad. But it should move slower than the background. It should move faster than the background. Maybe the background needs to move slower. Too slow. It's still too slow. Okay, that's much better. And then the ground also needs to move. And it's going to be similar logic here. This will be minus x plus game width. And we want this to move faster because it's closer to us. It does seem like we're moving fairly slow, which is not very exciting. So make this 5 to make it seem like we're moving a little bit faster. Make this 1. Okay, that's too fast. 4. Okay, let's just do 5. Alright, so I think that looks right. That looks pretty decent. We do kind of also want this idea of like a starting state. But we also want to change the style of the ground. I think it would be good. I think one other interesting thing would be changing which plane we're driving. We could do const plane equals get plane. Do that. I'll do const get plane. And yeah, it'll take state. And we'll return I'll say const planes equals okay, so we'll do return plane sub state.plane like that, and then we'll do const planes equals blue planes, green is green planes. And then in the, we'll say state.plane is a key of planes, key of type of planes. And then here, we just did a capital L instead of a lower. We'll fix that. And go to the app. We'll set the plane to be green. And then we gotta figure out how we change the color of the plane without changing it a lot. We don't want to detect too many click events. So we could say else if b.code equals shift. Is there really shift left? Okay, so we can change the color of the plane now. By pressing shift. All right, I'm happy with that. And then we have this idea of puffs of smoke. We could actually like animate it out with opacity, size. We don't even need the small puff. We use a large puff and just shrink it down, opacity it out, decrease the XR time. Okay. Alright, well, this is where we're at right now. I do need to take a break at the moment. I'm getting burnt out and I need to walk my dog. So, thanks everyone who joined and chatted. Appreciate that. I'll probably be back on in about an hour to do some leak code challenges, do some easy, mediums, and hards. But for now, yeah. I'll see you later. Bye.